Hello friends, welcome to my YouTube channels. Today I am going to discuss summary of the center vertical moment potential of the composite section. So I taken here one equilateral triangle, right angle triangle, rectangle and semicircle. So I will give the concept only. So this based on this concept, whatever question they will come, you can find out. So I will start this work. How many section is there? First you have to see. 4 section is there. You have to give the name of the 4 section. So take bigger section is 1. Take the bigger section is 1. Take 2, take 3, take 4. Anyone, either anyone 1, 2 because all are positive section. So if like this will be there, all are out external only. So formula will be A1 x1 plus A2 x2 plus A3 x3 plus A4 x4 divided by total area A1 plus A2 plus A3 plus A4. Suppose y1 na A1 y1 plus A2 y2 plus A3 y3 plus A4 y4. Total area what is A1 plus A2 plus A3 plus A4. So see this unknown A1 A2 A3 A4 unknown x1 x2 x3 and x4 unknown, which is area of the section 1, individual section center verti of the 1. Similarly that all notation. So here also similar work. What we have to do, given sections keep it in the first coordinate. Given sections keep it in the first coordinate. So this is origin, this is x, this is y. I taken given section in the first coordinate. So first coordinate y taken, both are positive in the first coordinate. So we'll start the work. Before this, triangle, semicircle and quarter circle concept I'll give. So suppose this is the semicircle. If you be there, center verti point will be this. Suppose this radius is r. If we'll see from the bottom, this is called 4r by 3 pi. If you are seeing, that means in this point, if you are coming from base, this distance is 4r by 3 pi. If you are coming from the top to this distance, r minus 4r by 3 pi. So you can write this like this, r minus 4r by 3 pi. If you are bottom, 4r by 3 pi, r minus 4r by 3 pi. Suppose you are seeing from this side, that means coming from this side to here, r. Suppose you are coming from this side to r, this side to this point, r only. So this is the concept for the center of gravity finding for semicircle. Suppose this is triangle. I am taking equilateral triangle. Equilateral triangle will be different from the right angle triangle. Okay. So both I will discuss now. Already we discussed all the video. Now see here, semicircle, equilateral triangle. This is called 8. This is height is 6. So how to find the center of gravity point? So this point I know. This vertical line, this point I know. So if we'll see from the top, we'll write 6 by 3. From here we'll write now, or suppose this height is 6h, this is height is h equal to b. So we'll write b h by 3. Suppose you are going from bottom, so 2h by 3. From this side you are seeing na b by 2. From this side you are seeing na b by 2. Because we have to reach this point only. We have to write this point. So this point will be same for both sides. B by 2, h by 3 or 2h by 3. If this will be same right angle triangle, this is height h, this is height b. Now look here. From here it will come. Here 2h by 3. So from the height 2h by 3. That means 2 into 6 by 3. So okay. How we will know? See, this distance is bigger. So 3 into 2 is 6. 3 into 2, 4. So this 4 and 2, this is h by 3. This is h by 3. Sorry. So what you have to do, think here. If you are seeing from the top, 2h by 3. Lower section, 2h by 3. Bottom section, h by 3. b by 2, b by 2. So from here again, same 2h by 3. From the bottom, you are seeing na h by 3. From this side, you are seeing again 2b by 3. This is the difference between right angle triangle and equilateral triangle. Because lower sections 2h by 3, lower sections 2h by 3. So its center of gravity point will be somewhere here. So see, this distance you will travel, more distance, see less distance, more distance, less distance. So 2b by 3, suppose this is 6, 8, no? 2 into 8 by 3, this distance. Then from this distance, 8 by 3. So from the bottom if you are going, h by 3. From this side you are going, b by 2. This way we are going, 2b by 3, 2h by 3. That only you have to remember. Rectangle already you know where which side you will come, it's the half distance only. Okay, so let us find the all the value a1, a2, a3, a4. Immediately we will find a1 na area of the rectangle 15 and this is 10. 15 into 10, 15 into 10, 15 into 10. A2. A2 na pi r square area of the circle, so pi r square by 2. A3. Half into height b by h. 5 into that 10. This height. Area of the triangle 1 by 2 base into height. A4. Same thing. 1 by 2 into 8 into 6. So area you know. Now how we find the x1? X1 equal to, see first always we'll measure x1 from the first horizontal line. So this is 15 by 2 here you write. You write what is here? 15 by 2 plus from the axis of reference what is the distance this one? 5. 5 plus 15 by 2. Because we have to take center vertex this first part only. But where this from the center of axis of reference? 5 centimeter away. So this one x2. X2 you are seeing from this way. You are seeing from this way. So r minus 4r by 3 pi. For that only I given this trick. What is? Suppose you are seeing from the x-axis. X-axis what is this side? So top side what is? R minus 4r by 3 pi. Then x3. X3 this one. Suppose you are seeing from this side na. This side what is? B by 2. B by 2 only. So 5 by 2. But where? 5 plus 15. X3 is equal to 5 plus 15 plus 5 by 2. 5 plus 15 plus 5 by 2. This side we are seeing na b by 2. Okay, now x4. X4 this from this side. So see this equilateral triangle b by 2. That means 8 by 2. 8 by 2. But from where? From where this? This is 5 plus what is this one? 8. This is 7. This is total 15. 8, 7. So 8 plus 5 plus 7 plus 8 by 2. This is the x1, x2, x3, x4. Then how to calculate the y1, y2, y3? So see here. If you take y1 from the base, this height 10 by 2. Then you take y2 from this height. If you see this height, see this height na radius. So in this point, how we are taking r only. So you write r only. Then y3 from this side. This is 3. y3. This height. What is this height? h by 3. So that means 10 by 3. 10 by 3. Then y4. y4 this. From base. What is base? h by 3. So 10 plus h by 3. 6 by 3. So this way we can calculate y1, y2, y3 and x1, x2. If substitute you will get the center vertex of the composite section. You will get the center vertex of the composite section. So whatever sections will come, moment of inertia already we did. Now I am not going to continue moment of inertia. It will get long. So composite sections whatever will come. This is the method. These three you remember. These three you remember. You can solve the any composite section of center of gravity. Okay. Okay, students. Thank you.